In this video, we are going to go through an example of evaluating an AI tool, and in this case, we are going to talk about connected papers. Connected papers allows you to build graphs that are visually interesting based on information from Semantic Scholar. You can use connected papers to get a visual overview of a new academic field, perhaps. Maybe you want to make sure you haven't missed an important paper. You can create bibliographies for your theses and discover the most relevant prior and derivative works. We scroll down a little bit further here as we evaluate this website. We think about maybe other information here that's available. It's sending me information about Twitter and joining their mailing list. What's more important is things up here at the top where it talks to us about its About page, and there's also this information about logging in. So as you can see here, I can only do 2 free graphs a month, and then I might have to upgrade. I'm going to check my graph history here in a moment, but the next thing we want to look at, like I said, is this About page. If I click that About page here, this About page for connected papers talks about how it works. So for them, they describe their process as being able to create each graph. They analyze about 50,000 papers to select few dozen with the strongest connections to the origin paper. They then arrange those papers according to their similarity, which means that even papers that do not directly cite each other can strongly be connected or very closely positioned. So this is not a citation tree. There are other databases that are creating things like citation trees that are visually interesting. But their similarity metric is based on the concepts of co-citation and bibliographic coupling. So according to those measures, 2 papers that have highly overlapping citations and references are presumed to have a higher chance of treating a related subject matter. They say that their algorithm then builds a force-directed graph to distribute the papers in a way that visually clusters similar papers together and pushes less similar papers away from each other. They then highlight the shortest path from each node to the original origin paper in similarity space. And like I said before, this database is connected to Semantic Scholar. Let's check out one of those other graphs that I had already made. Well, first we're going to check on its price. But let's go to, let's see if it'll let me look at my graph history here. Oh, no, it wants me to log in. So if I just pick this, maybe I'll take this one here. So this third one down, we're going to take that paper and we are going to go ahead and look at the graph that it just built and the differences between the different nodes here. So it's got different nodes to yoga-based lifestyle and COVID-19. Then we've got COVID-19 and yoga. We've got more over here on health and therapeutic effects of yoga. Way out here, we've got ratio-based imputation for high missing gap. I'm not entirely sure what that has to do with what I want. All right, I can look at prior works, derivative works. I can see things in a list. I can filter. So filters are nice. And I can see a few other things here. So if I want to see different graph versions, full screen of that graph, I might want to download it. I can share it. This is a useful tool for certain things. However, if you're doing a more in-depth analysis, a systematic review, you may want to do what's known as a protocol, and you're definitely going to want to go into the library's databases to run those protocols. But this can be a nice visual overview of a particular academic field.